Okay, so welcome to this class, Business Statistics 2. And our first topic is Introduction to Probability Distributions. Now, when you talk about a probability distribution, it is very close to what we learned in Business Statistics 1 called a frequency distribution, like the one shown here. Is an example of a frequency distribution table. So to convert this table into a probability distribution, we just need to find the probabilities, the probability of each of the values of X in the table there. So let's get the probability values given here. For instance, the probability that X is equal to 0. Let's have someone unmute themselves and answer the question. What is the probability that X is equal to 0? From the basic definition of probability using classical approach, what is the probability that X is equal to 0 according to the data given here? Okay, someone? So the probability here is 4 out of, what's the total number of observations in this table? If you sum the frequencies, what is the value? How much? What is the total?
29.
F? How much? 29, huh?
29.
Yes, 29.
29. So the probability of X being 0 is 4 out of 29. And the probability that X is equal to 1 is 5 out of 29.
29.
And the other one is 10 out of 29. 6 out of 29. And finally 4 out of 29. So here I can put the values 4 out of 29, 5 out of 29, 10 out of 29, 6 out of 29, and finally 4 out of 29. And you notice that if you total those probabilities, if you sum all those probabilities, you will get equal to 1. You will get that is equal to 1. Okay. So now what we end up with, if you are to ignore this column, is a simple probability distribution. That's an example of a probability distribution. So when you talk about a probability distribution, we're talking about a table like this one. A table like this, which assigns probability values to all the possible values of X. It can be in form of a table, or it can be a graph. Okay, it can be a graph. So you can represent these values of X graphically. So I can center the values of X to have them like this: 1, 2, 3, 4. Then I can draw a histogram. So assume this is 4 out of 29. This is 5 out of 29, not drawn to scale. 5 out of 29. We have 10 out of 29. 10 out of 29. What was here? This was 6, huh? Yeah, 6 out of 29. 6 out of 29. And finally, we have 4 out of 29. Is it 4? What is the last value here? 4, isn't it? Huh? 4 out of 29. So that's again an illustration of a probability distribution. So it can be in the form of a table or a graph like this one. And finally, it can be in form of a formula. And in most of the cases in this class, we shall be using a formula to represent a given probability distribution. When you use a table, so when you use a graph like this one, it's always good you comment on the shape of the distribution. Here you talk about the shape of the diagram that you're talking about. And most of the most widely used shapes here are, you can have a rectangular shape. It can be rectangle. These are the most widely used shapes. There can be others. You can also have symmetrical shape, or you can have a skewed distribution. So those are the main types of distribution. It can either be rectangular, symmetrical, skewed, and so on and so forth. So now, before I define the term probability distribution more formally, I want us to recall some basic things. And I want us to start by recalling the term variable. I want us to recall the term variable, and we also see how variables are classified. So let's recall the meaning of the word variable. So let's recall the meaning of the word variable. Is there anyone who can recall the meaning of the word variable as used in Business Statistics 1? What is a variable? A variable as used in statistics. So we can simply say that a variable is a characteristic under study. It is a characteristic under study whose value, or which assumes different values, a characteristic under study which assumes different values for different elements. Okay, where elements here are the individuals under study. Okay, so something like what? Something like the weight. For instance, weight of students in this class. The weight of students in this class will take different values from one student to another. If it's not changing from one student to another, then we don't call it a variable. We call it a constant. Okay, things like height, things like height of students in this class, and even the gender. Gender of students in this class is not constant, because I know there are male and female students in this class. If everyone in this class was male, for instance, then gender will not be a variable in this class, to be a constant. Or if everyone in this class was female, then gender will not be a variable in this context. So the value must be changing from one individual or from one element to another. Okay. Now, variables are broadly classified into two. Variables are broadly classified into two. We have what we call quantitative variables, and on the other hand, we have qualitative variables. When you talk about quantitative variables, these are variables whose data takes numeric form. So the data is in form of numbers. Okay. Things like height, things like weight, things like time, maybe time taken to run a marathon, and so on and so forth. Okay. When you talk about qualitative variables, here the data takes non-numeric form. Usually, it takes the form of names. The data comes in the form of names or labels. For instance, gender of a person. The gender of a person is not and will not attract a numeric form of data. It will either be the name male or the name female. Or you can use a label like M for male or F for female. So those are labels. The color of your eyes. So the color will take names. For instance, maybe your eyes are black, maybe they are green, maybe they are blue, and so on and so forth. Okay. Now our focus in this class or in this topic will be the quantitative variables. So I'll go further and show you the classification of quantitative variables by saying that quantitative variables are broadly classified, or again classified into what we call discrete variables, and on the other hand we have continuous variables. So quantitative variables are either discrete variables or continuous variables. Now, when you talk about discrete variables, So these are quantitative variables which take, these are quantitative variables which take some specific numeric values. Huh? So I should have said these are variables which take some specific numeric values, especially whole number values. So they take some specific numeric values, and in most of the cases, they take whole number values. Things like what? Number of students in a class. Number of students in a class. Okay. Number of rooms in a house. Number of programs offered by a university, and so on and so forth. Okay. So remember I said that it takes some specific whole numbers, some specific numeric values. The numbers are not necessarily whole numbers. We have things like the shoe size. For instance, the shoe size of students in this class, you notice that shoe sizes do not necessarily take whole numbers. Sometimes they take a whole number and a half. For instance, number 3.5, number 4.5, number 4. So you find that is a mixture of whole numbers and some specific fractions, some specific. So the key word here is specific, not actually whole numbers, because sometimes you get fractions. So those are what you call discrete variables, discrete variables. On the other hand, continuous variables are those which take all the possible numbers. That's a very theoretical statement, all the possible. So they take all the possible numbers within a given interval. They take all the possible numbers within a given interval. Okay, something like height is a variable. Height can take any number. So that means they take both whole numbers and decimal numbers. They take both whole numbers and fractions. Okay, things like height. Height can be a whole number or it can be a fraction. Okay, things like weight. The time taken for someone to run a marathon, all those are continuous variables. All those are continuous variables. Okay, so that's the bit I wanted us to recall. We'll not go to the other class. We'll not go to the classification of qualitative variables because we are not interested. We're only recalling what is important in our context here. So with that, now I want us to define the term probability distribution. Okay. So probability distribution. And we start by saying that a probability distribution is similar to a frequency distribution. We've just mentioned we've just recalled what is a frequency distribution. Is similar to a frequency distribution, but it shows probabilities. It shows probabilities instead of frequencies. Shows probabilities instead of frequencies. So simply put, we can say that a probability distribution is a table or a graph or a formula. You can take any of those three forms. It can be a table, it can be a graph, it can be a formula. Okay, that specifies the probabilities that specifies the probabilities associated with all the possible outcomes, the probabilities associated with all the possible outcomes of a variable. Okay, there's something I want you to note. This phrase here. Please note the phrase that I've underlined in green. All the possible outcomes of a variable. Sometimes it can be all the possible values of an experiment. Okay, or it can be a variable or experiment. In probabilities, we talk about experiments quite often. Okay, so the part that I've underlined is actually the definition of what we call the sample space in the context of probabilities. Okay, so the sample space, we want to recall this. The sample space is the set of all the possible outcomes in an experiment. Of course, we assume that the experiment is random in this case. So the set of all the possible outcomes in an experiment is what we call the sample space. For example, I suspect that you know that the sample space is usually denoted by letter S, capital letter S. For example, consider this experiment of tossing a coin once. So toss a fair coin once. If you toss a fair coin once, then the sample space, which you're going to denote by letter S, and you know, as you know, elements of a set are enclosed in brackets. So when you toss a coin once, what are the possible elements? What are the possible outcomes? Just say the answer so that we move on. When you toss a coin once, what are the possible outcomes?
Heads or tails?
Yeah, good. It is either heads or tails. H or tail. H or T. We use the labels H or T. Okay. Then do we know the probabilities associated with each of those possible outcomes? Like for instance, probability of getting ahead. The probability of getting ahead when you toss a fair coin once. Just say the answer.
Oh.
Yes.
Half.
1/2. And also the probability of getting a tail is also 1/2. So if you are able to create a table that is assigning various probabilities to each of the outcomes in the given sample space, then we'll end up with an illustration of what we call a probability distribution. So let's create a table here. So here we have the outcome, which is H or T. Then if you can get these values, then you end up with a probability distribution. And you've just told me that the probability of getting ahead when you are working with a fair tail is 1/2. So that's an example of a probability distribution. Okay, you may want to represent this story. Most of the time, this outcome is converted into numbers. So instead of having H or T or these labels, you convert it into the number of success outcomes, but we'll go to that later. Okay. So this distribution can be represented graphically in this way. So you can label this part H, you can label this part T. Then you'll end up with that kind of distribution. This is half. So you'll end up with, so that's a probability distribution. And we said that we always mention the shape, and here the shape is rectangular. The shape is rectangular, okay? So you notice that if you take a half plus a half, you'll always get 1 all the time. Huh? You'll always get 1, okay? Now, if, suppose you do this, let's have another illustration. Suppose you toss 2 fair dice. Let's remain with the coins. 2 fair coins. And let your variable of interest, be the number of heads observed. So here we are defining a variable, or variable x, as the number of heads observed. Okay, so let's list the sample space. So the sample space, when you toss 2 fair coins, and there are 4 possibilities. You can get a head in the first coin and a head in the other one. You can get a head and a tail, tail and a head, or you can get T and a T. So there are 4 possible outcomes, okay? But now the story has changed here. We are looking for X. So let X be the number of heads, of H observed. And you notice that the number of heads can range from 0 to 2. Like in this case here, these are 2 heads. This is just 1 head. This is 1 head. This is 0 head. So X here takes the values 0, 1, or 2. Okay, and then each one of them has a corresponding probability. So for instance, what is the probability of observing 2 heads, H and a H? What's the probability of getting head? So what's the probability of getting head followed by a head? Any ideas? Yeah?
A quarter.
Quarter, 1/4. The probability of getting a head followed by a tail is?
A quarter still.
Probability of getting a tail followed by a head is also a quarter. And the probability of getting, I'll explain later why that is so. It's also a quarter. So let's come up with a probability distribution now using X, not the labels H and T. So our distribution, probability distribution look like this: X, which will take value 0, 1, or 2. So what is the probability that X is equal to 0? That's the question. Probability that X is equal to 0. We also need probability that X is equal to 1. And finally, we need probability that X is equal to 2. The probability that X is equal to 0 is given by probability that we get that. We've said it is 1/4. So this is a probability. This is 1/4. What about probability that X is equal to 1? Is given by HT or TH. So what do we do with those 2 probabilities? We add them. We add them. So this is the same as 1/4 plus 1/4, which is equal to 1/2. So this probability here is 1/2. Then finally, probability that X is equal to 2 is the same as probability of getting head, which we said is 1/4. You will always notice that if you sum up this, you must always get 1. Okay. So if you want to represent this graphically, you will end up with something like this. So here you'll have X, and here you have the probability. I am going to center the values of X so that I can have a histogram. So I'm going to have 0 there, 1, and 2. So the first bar will go up to that point, assume that is 1/4. The other one will be twice as long, which is 1/2. And the final one will be 1/4. So that's what you have. That's the distribution graphically. What kind of shape is that? What shape is that? This is symmetric, because you can divide this distribution into two identical and equal halves like that. So this symmetric distribution, and so on and so forth. Okay. All right. So now that's what we call probability distribution. Now, probability distributions can be broadly classified into two. Probability distributions can be broadly classified into two. We have what we call, and this classification here depends on the type of variable. And we've said that we're working with quantitative variables. So based on the variables, probability distributions can either be discrete probability distributions or continuous probability distribution. And a probability distribution is said to be discrete if the variable in question or the variable involved is a discrete variable, which I've already defined. And on the other hand, a probability distribution is called a continuous probability distribution if the variable in question is continuous. So that's simple. So if you look at the examples that we've just given here, for instance, this, I think this is a better example. You'll notice that X is a discrete variable because it takes some specific numbers. And in this case, it's taking purely whole numbers. So this illustration is an example of a discrete probability distribution. Okay. Now let's look at let's list the examples of discrete probability distribution or distributions. There are quite a number of discrete probability distributions, but in this class, our discussion will be restricted to binomial distribution or binomial probability distribution and the Poisson probability distribution. So we shall be focusing on those two, the Poisson and the binomial. Okay. Now, examples of continuous probability distributions. So in this class, we shall only be discussing one, which is the most important probability distribution or continuous probability distribution. This is known as the normal distribution. The normal distribution. There are of course others like the exponential distribution, the gamma distribution, beta distribution, Weibull distribution, but we are not going to discuss any of the others. So our focus in this class will be those three probability distributions, two which are discrete and one which is continuous. So let's start with the binomial distribution. Unless there's a question,